sixes, 2 6s. Here we go. Ready? And no! Well, 1 6. That's not bad, but not 2. All right, here we go. Got my deck of cards here. 3 of hearts. 3 of hearts. 3 hearts ready. Oh, 10 of diamonds. Bummer. Well, what were the chances, right? At least I tried. Welcome to investigation number 10, 4th grade on probability. What were the chances that I was going to get a 2 6s or the right card? Guess not. Well, that's what we're going to be talking about today in our math lesson, in our investigation. So what you are going to need your math book, a piece of paper, a pencil, the lesson activity 47 sheet in your packet, and you are going to need a die, 2 dice. Okay, so hopefully you have those things with you. Initially, we're just going to work with 1, but then you're going to end up working with 2 with a partner at home. Hopefully you can find someone at home that will help you with this. So let's get started. So what I was showing you right there is I was doing something that involved chance. So when I had the cards, that means it's like if I say I want to get a 3. Ooh, 7. There's a chance I'm going to get it. There's a chance I'm not. And apparently I'm not. So a lot of times you don't know the result of an outcome. And that's where chance is involved. Maybe I could get it. If I roll the dice, there's a chance I could get 2 6s, but there's also a chance I won't, okay? And the degree of the likelihood, there's a likelihood that maybe you can get these things, and that has to do with probability. If we look, I know in the past we've always looked for smaller words in bigger words, and if you look, there's like probable, or you think probably, that means it might not, maybe. Most likely we'll see. Okay, so that's what we're going to be talking about today. You have a picture of a spinner in your book. I have a picture of that spinner up here. Okay, so you have your little spinner. Remember, when you have a spinner, you take it and you move this middle section around. Okay, as you're taking a look at the spinner, it's divided into 6 parts. These 6 parts, let's count them. 1, I'm going to start on this A. 1, 2, 3, 4, 5, 6. This is the same spinner that's in your book. And they are divided into parts called sectors. That's this thing, okay? So these are all considered sectors. If we take a look at that, assuming that it's balanced and fair, then what's going to happen is each sector is 1/6 of the spinner. And remember, with fractions, your denominator on the bottom is the total number of sections, 1, 2, 3, 4, 5, 6, and then the 1 section is considered 1/6, okay? So what we're going to do is we're going to follow the questions. We're going to take a look at the questions, and as you know, with investigations, we go through them all together, and we are going to ignore the possibility that this spinner is going to land on a line. We're always going to assume, for our sake in these questions, it's going to land on one of these sectors. Okay, so let's take a look at number 1. They said if the arrow is spun once, what outcomes are possible? So in other words, and we can write this down for number 1, you should be turned to page 636. I'm sorry if I didn't tell you that in advance. We're on investigation number 10, page 636. So the question again, if the arrow is spun once, what outcomes are possible? So what we're taking a look at are what are the levels, or I'm sorry, not the levels, what are the letters the spinner could land on? And we have either A, B, or C. You don't have to write down multiple A's because we know that it's either A, B, or C. So then we go here, number 2. On which letter is the arrow most likely to stop and why? Well, if we look over here and we look at the letters, we need to count how many of each letter. So if we look at A, we have 3 A's, I'm going to put a little 3 underneath here. We have 2 B's and then 1 C. Well, knowing that, what is the possible outcome? Which one is it most likely to land on? And we would say A, comma, because there are more A's than any other letter. Does that make sense? The probability, the chance that you're going to land on an A is higher because there are more A's. It takes up like half the spinner. Okay? Now, number 3, write the possible outcomes of a spin in order from least likely to most likely. So we want to take a look at, well, least likely is probably going to be the sector that has the smallest amount of numbers on it. So if we look over here, C would definitely go least, then B, then A. And the reason why we say the least likely is C is because there's only one C, right? Okay, number 4. Which outcome of a spin is twice as likely as the outcome C? Well, we take a look at C. There's only one C. Well, what's double of how many C's? Well, you look at how many C's there are. There are 1. What's double of 1? 1 plus 1? 2. Which one of these letters has 2? And that would be B. So we go on to number 5. If the arrow is spun many times, then about half the outcomes are likely to be which sector? Well, if we're saying half, so it's many, many times, let's say we did it like 10. Of the 5, which one is it going to land on? Well, half of the whole spinner is A. So we would determine that to be A. Number 6, multiple choice. If the arrow is spun many times, then what fraction of the spins are likely to stop in sector C? Then what fraction of the spins are likely to stop? Well, if we take a look at our fractions, if we have 1 out of 3, 1 out of 2, 5 out of 6, or 1 out of 6. Well, remember, how many sectors are there? There are 6. And how many of them are C? It'd be 1. So our answer for that would be letter A, because that would go with the fraction 1/6. Number 7. In 60 spins, about how many times should we expect it to stop in sector C? And they have about 6 times, 10 times, 20 times, 30 times. Well, let me show you a way to figure that out. So we originally said that fraction would be 1/6. And now they're saying in 60 times. Well, think to yourself, how much did you have to multiply times 6 to get 60? And that was 10. So then we would multiply 1 times 10, and that would also give us 10. So our answer for number 7 would be B, about 10 times. Okay, moving on. So the probability of an outcome can be expressed as a number ranging from 0 to 1. An outcome that cannot happen has a probability of 0. Like, there's no way. Will it probably happen? No, that's 0. An outcome that it is certain, like this is going to happen no matter what, has a probability of 1. Like 100% this is going to happen. An outcome that could happen but is not certain to happen is expressed as a fraction between 0 and 1. So, in other words, if they say there's a 100% chance of rain, right? So let's take a look at that. Like, that is certain that's going to happen. If they say there's 0% chance of rain, that means it's not going to rain. There's no way, 0%. But let's say there's 40% Well, it might rain. It's a little on the low end though. So that's what we're talking about. Certain is 100%, or 1. Not going to happen is 0% or 0. So we're going to use the spinner at right to answer problems 8 to 10. And thankfully this is our same spinner here. So we look at number 8. What is the probability that the arrow will stop in sector D? Why? Sector D. Well, I'm looking at this. There is no sector D. So the probability of landing on sector D is 0. And it asks why. Well, there is no letter D. It's a probability of 0. Like, there's no way that's going to happen. 0%. Number 9. What is the probability that the outcome will be one of the first 3 letters of the alphabet? Well, what are the first 3 letters of the alphabet? A, B, C. So what is the probability that this is going to land on an A or a B or a C? And obviously 1 or 100%. We're not going to do percents right now, but let's say it's 1. All the letters are the first 3 letters of the alphabet. It's kind of a weird question, but that's what they're going for, is they want to say, like, what's the probability? What's the chance? Okay? So then we look at number 10. What is the probability that the arrow will stop in sector C? So we go back to that same fraction we've been talking about. How many do we have sectors? We have 6. That's the bottom. C is 1. So moving on, we show a standard dot cube at the right. So I got one right here, and hopefully you have that as well. It says, what numbers are represented by the dots on the faces of a dot cube? So I'm looking at mine, and hopefully the one you have in front of you, and we have, the numbers are 1, 2, 3, 4, 5, and 6. So number 12. If a dot cube is rolled once, which number is most likely to end up on top? Why? So out of all these, which is the one that's most? And the answer to that is none of them. And we would put that down for 12. None of them is most likely. None of them. They are all equally likely. There's nothing that's most, because if you look at the numbers, they're all different numbers, and there's one for each. There's no way. Okay? So then we take a look at number 13. If a dot cube is rolled many times, about how often would we expect to roll a number greater than 3? So we have 4, 5, and 6. And then our answers are less than half the time, about half the time, more than half the time, or none of the time. Well, if we look, we have 1, 2, 3, 4, 5, 6. And if we roll a 4, 5, or 6, that's 3. 3 out of 6. 3 out of 6 is half the numbers. That's about half. So then our answer for 13 would be about half, and that would be 13B. About half. Number 14, if a dot cube is rolled once, what is the probability of rolling a 7? So remember, 0 means 0 probability, not going to happen. 1 means it's going to happen, absolutely going to happen. So we look at number 14, and again, it asks, what's the probability of landing on a 7? I look, there is no 7, so what's our probability? 0. If with one roll of a dot cube, what is the probability of rolling a 1? Well, again, we go with our fraction. Just like this had 6 sectors, that's our bottom number. And then the question is asking you, rolling a 1, how many 1s are on the dot cube? 1, 1/6. All right? So now we look at number 16. How would we describe the likelihood of rolling a 6 with one roll of a dot cube? So our choices are very likely, just as likely to roll a 6 as not to roll a 6, unlikely, or certain. Well, it's funny because I know whenever I try to roll a 6, it usually does not happen. But out of our choices, we look over here, there's 1. So it's, out of all of these, how likely is it? It's unlikely. It might happen, but probably not, because that's the last option. And it's only one of the options. So for number 16 is 6. Okay, the chance of an event is sometimes expressed as a percent from 0 to 100%. And that's what we talked a little bit about here. For example, if a meteorologist forecasts the chance of rain is 20%, it's probably not going to happen. It's a very low chance that that's going to happen. But if it says it's 100%, that's basically saying the same as 1. Like this is going to happen for sure. So looking at number 17. The weather forecast stated that the chance of rain is 40%. According to the forecast, is it more likely to rain or not to rain? Well, think about 40. How close is 40? Closer to 0 or closer to 100? And 40 is definitely closer to 0, so we would say not to rain. And then finally, number 18, and then we're going to get to our activity. Number 18, the meteorologist said that the chance of rain is 80%. This means that the chance it will not rain is what percent? So they're saying it is going to rain, 80% chance. Well, what's the chance that it's not? So we think to ourselves, 100% chance means most definitely. So what I'm going to do is I'm going to take 100 minus the 80, and I get left 20. So my answer would be 20% chance of not. All right. As you know, whenever we do investigations, it always takes us a while, but this really helped us walk through probability and chance, and I hope you learned from that. And now we get to do a fun activity. So what I would like for you to do is get out the lesson activity 47. Okay, it looks like this. I am going to put my name up at the top. I hope that you do that too. Okay, and what I'm going to need, and we're going to do experiment 1 together. You are going to do the bottom part with a partner at home. Okay, so I'm turned to page 638, and it says work with a partner for this experiment. You and your partner will roll one dice cube 36 times and tally the number of times each face of the dot cube turns up. You will record the results in experiment 1 table on lesson 47. Before starting the experiment, predict the number of times each outcome will occur during the experiment. Write your predictions in the column labeled predictions. So we have 36 rolls. So what I'm going to do, and you're like, well, so this says 36, so that means these have to add up to 36. So I'm going to look here. I'm going to say, okay, 1, 2, 3, 4, 5, 6. Should I predict, well, I'm going to get 6 1s, 6 2s. Do you think it's going to be equal? What do you think? Don't know, huh? So I would go, how about this? I tend to roll a lot of 2s. So how about I'll go 2, 10, and then I'll say, I'll do another 10, 2, and then I'll say 6 and 6. So the key is whatever you predict here. Now you can do this with me because you're going to have to do this down here. So we think, all right, make sure that this adds up to 36, otherwise this isn't going to work. So you think 2 plus 10 is 12. This is 12, 12. 12 times 3, 36. So we're good. So now begin rolling the dot cube. Make a tally mark for each roll in the appropriate box in the tally column. When all groups have finished, report your results to the class. Well, you're just going to report it to me through paper. Okay? So we're going to do this really, really quick. So can you roll it as well? That is my cameraman back here, and he's gonna roll it after I do it, so we can take turns. Ready? Go. Go, roll it. So I got a 6. I'm gonna put one in. 3. 1. Go. 6. Do you see what I'm doing? Every time we roll, I'm just tallying it. Okay? 3. Oh my, lots of 3s. Oh, crazy. One. 36 times is a lot of times, but we're going to follow directions. 2. 6. Unbelievable. Look at all the 6s. Another 6. 3. A lot of 6s and 3s. 5. 3. Ooh, the first 4. So I'm going to stop here a second. So I have 1, 2, 3, 4, 5, 6 plus 10. Yay, 20 more to go. Go ahead. Another 6. 5. Another 5. This is some interesting stuff to watch. 6. 4. 2. 6. Wow, that is crazy. 2. 2. 5. 4. 6. That crazy 6 keeps coming up. And then when I need to do it in the game, it won't work. Maybe this will be my lucky day. 2. 5, 10, 15, 20. 22, 23, 24, 25, 26, 27, 28, 29, 30. 6 more times. Did I count this one? I don't think I did. I don't think I did. So let's do it. 31. 32. 33. 34. 35. Oh, the last one. Hopefully we got the math right on this. And 5. 36. Okay. So we can take a look over here. So now, after you do that, hopefully this will add up to 36. If not, then we'll adjust it. So I look at my prediction for 1s was 2. My tally indicates 2. So I was actually right. I only did get it 2 times. For 2s, I predicted 10, and I actually got 6. 3s, I predicted 6. I got 7. That's pretty close. 4 predicted 6. I got 6. 5s were 10. And I got a 6. And then for 6, I predicted 2. I actually got 9. Wow. So now, in order for us to make sure we did this right, it says, so we need to add this together. So 2 plus 6 is 8. 8 plus 7 is 15. 15 plus 6 is 21. 21 plus 9 is 30. 36. So that is how you do that. Okay? Now, if you are like watching me and you're like, okay, I get it, I want to do my own, that's totally fine. You don't have to have this be exactly, I'm just doing this to show you how to do it, okay? So now we go back in our book. In our book it says, make a bar graph using the data from your table. You do not have to do that. You can skip number 19. We've already worked with bar graphs. We've done all those other things. I am sure that you are good with that, and that is fine. So number 20, what conclusions can you draw from the results of experiment 1? Well, if we take a look, and we can do this verbally, What conclusions can you draw from the results? I guess, I mean, it's just all of the results are equally likely. I mean, there's only one of each. So then we look at 21. Is it easier to compare data using the bar graph or the table? Well, had we made a bar graph, maybe it'd be easier to see, but I guess here it's also easy to see based on the numbers. And I think this is my highest number. And then might have been nice to see like all of these would all be the same. So I guess the bar graph would be easier. All right, so now for experiment 2, you are going to grab a partner, and you're going to do 36 rolls of 2 dot cubes. You're going to do the same thing where you are going to write down your predictions. Make sure that your numbers add up to 36. Then you and a partner are going to begin rolling the dot cubes, and then you're going to create a tally and then write down your total frequency. What I'd like you to do is when you're done with that, you can complete numbers 22, 23, and 24 on down here on your sheet. When it asks which outcomes occurred most frequently, why? I mean, basically they're saying which one did you get the most of? And why? Well, why is because that's the one that you rolled. I mean, again, I'm not quite sure. Maybe is that like that certain combination? There are more combinations of getting that. See if you can figure that out. Which outcomes occurred the least? Give an explanation. And what conclusions can you draw from the results of experiment 2? See what you find out. Again, you'd only have to have one thing. The results from experiment 1 is it was all equally likely. It's just chance that I got 6 the most when usually I never roll a 6. Okay? Number 25. What are all the possible combinations you could roll with the sum of 7 as the result? You can do number 25 for extra. You don't have to, but you can go up to 24. And that is the end of our probability investigation number 10. I hope you have fun learning about chance and probability. Have fun. Good luck.